Okay, we're going to look at orders of magnitude next. So what an order of magnitude means is certain numbers are so large that they need to be expressed in scientific notation, or else the number is so minuscule that it also needs to be expressed in scientific notation. Scientific notation is the same as standard form, which is also known as index notation. Okay, so these are the steps that you follow to be able to state how many orders of magnitude there are in the difference between two particular numbers. So step 1, write the numbers in the form of a by 10 to the power of n, where n is an integer and a lies between 1 and 10. So basically write it in scientific notation first. Step 2, if your value for a, if it's less than 5, the rule is you round it down to 1. Okay, so this is important now. Don't confuse with any other types of rounding. You round it down to 1. If a is less than 5, you round it down to 1. Why? Because 10 to the power of 0 is a 1. So we want to write everything in powers of 10, basically, for orders of magnitude. If a is equal to 5 or above 5, you would round the number for a up to 10, because 10 on its own is the same as 10 to the power of 1. After you've done that, you'll tidy it up. Okay, you'll write the whole number as a power of 10. You will then place the larger power of 10 all over the smaller power of 10 and divide the two numbers. Okay? So let's look at the first example. By how many orders of magnitude do the following numbers differ by? So the first number is 2,308,490 and the second number is 5,631. So first off, we're going to write them both in scientific notation or standard form. So here, the decimal place was here. So I'm going to bring it back 1, 2, 3, 4, 5, 6 places to the left. So it's going to end up being 2.308490. You can put in the O if you want, it doesn't make a difference. Multiplied by 10 to the power of. I brought it back 1, 2, 3, 4, 5, 6 places to the left. And it was a very large number to begin with, so it's power of 6. Now, this is your value for a. Remember from step 2, if a is less than 5, you round that down to a 1. So it's 2.3, which is less than 5, so I'm now calling it 1 multiplied by 10 to the power of 6. 1 is the same as 10 to the power of 0 multiplied by 10 to the power of 6. And then if we apply rules of indices, when the base numbers are the same and you're being multiplied, you would add the powers. So that will end up becoming 10 to the power of 0 plus 6 is 0. So that's the answer for the first one. I'm now going to do the exact same thing for the second number. So I'm going to write it in scientific notation. Okay, so the decimal point was here, so it's going to be 1, 2, 3. So it's going to be 5.631 multiplied by 10 to the power of 3. You brought it back to the left and it was a large number, so it's a positive power. Next, you look at your value for a. And remember from step 2, if a is greater than or equal to 5, you would round the number up to 10. Well, I've got a 5.631. That is greater than 5, so I'm rounding that up to a 10. And it's 10 to the power of 1. Multiplied by 10 to the power of 3. Rule of indices. When the base numbers are the same, you would add the two powers. So that's going to end up being 10 to the power of 4. Okay? So I'm just going to highlight both answers. Okay, so basically, this number had 6 orders of magnitude. This number had 4 orders of magnitude. The question said, by how many orders of magnitude do they differ? Put the larger one over the smaller one. 10 to the power of 6 is larger than 10 to the power of 4. So you're now dividing them. Rule of indices. When you're dividing them, you can subtract the power. So it's going to be 10 to the power of 6 minus 4, which is 10 to the power of 2. So again, your final answer. It said by how many orders of magnitude do they differ? They differ by 2 orders of magnitude. So your answer is 2. Okay, the next example is by how many orders of magnitude do these two numbers differ? So step 1 again, write them in scientific notation. So for this one, I have to bring the decimal point to the right because it's a tiny number. So 1, 2, 3 places to the right. So now it's going to be 4.2 multiplied by 10 to the power of. When you had to bring it right and I moved it 3 places, it's a minus 3. Now, when your value for a, if it's 5 or if it's less than 5, you round it down to a 1, so that's going to go down to a 1. No, 1 is the exact same as 10 to the power of 0. Rules of indices, you can add the two powers. 0 plus minus 3 is minus 3. So basically that number, it has a negative 3 orders of magnitude. Let's do this number. So look where the decimal point was, it's out here. So bring it back 1, 2, 3, 4 places to the left so that we land on a number between 1 and 10. So that's 7.6213 multiplied by a 10 to the power of a positive 4. 7 is your value for a. If it's greater than or equal to 5, you round up to 10. So that's a 7, which means I round that up to a 10, which is 10 to the power of 1. Multiplied by a 10 to the power of 4. Rules of indices, you can add the two powers. So I'm going to get a 10 to the power of 5. So that number has 5 orders of magnitude. Now the question said, by how many orders do they differ? Put the larger one over the smaller one. That's a larger order of magnitude than this one. So it's going to be 10 to the power of 5 divided by 10 to the power of minus 3. Now, rule of indices means you can subtract the powers. So it's going to be 10 to the power of 5 minus 3. Keep that in a bracket because it's already negative. That's going to be 10 to the power of. A minus multiplied by a minus is a plus. So that becomes 5 plus 3, which is 10 to the power of 8. So the answer, those two numbers differ by 8 orders of magnitude. So that is your answer. 8 orders of magnitude. Okay, what I want you to do now is go and do these two questions. Go and find how many orders of magnitude they differ by. Pause the video and then come back and look at the solutions. Okay, so the first one, writing that in scientific notation, it's by 10 to the power of 11. That's greater than 5, so it rounds up to a 10, which is 10 to the power of 1. Okay, apply your rules of indices and add the powers, so you get 10 to the power of 12. So that number has 12 orders of magnitude. This one, 23 million, bring it back to the left. You're going to get 2.3 by 10 to the power of 7. 2.3 will round down to a 1. 1 is the same as 10 to the power of 0. Rules of indices, add the powers, you'll get 10 to the power of 7. So that number has 7 orders of magnitude. Put the larger number over the smaller number and divide. So it's going to be 10 to the power of 12 over 10 to the power of 7. Subtract the powers, so you'll get 10 to the power of 5. Therefore, your answer is, there are 5 orders of magnitude in the difference. Okay? The next one. 0.1, if you write that in scientific notation, it'll be 1 multiplied by 10 to the power of minus 1. 1 means it goes to 10 to the power of 0. Rules of indices means you end up with 10 to the power of minus 1. So there are minus 1 orders of magnitude for that number. For this number, you're bringing your decimal place to the right. You're bringing it 4 places to the right, so it's a minus 4. 3.8 is less than 5, so you round down to a 1. 1 is the same as 10 to the power of 0. Add your indices and you'll get 10 to the power of minus 4. So that number has minus 4 orders of magnitude. Now, put the bigger number over the smaller number. You might think that 10 to the power of minus 4 is a bigger number than 10 to the minus 1. It is not. Okay? And if you throw it into the calculator, it'll show you the two decimals, alright, and you'll see which one is smaller. Or alternatively, if you can remember your rules of indices from junior cert, 10 to the power of minus 1, if you were to write that in fraction format, which means if you were to take it out of negative powers, that would be the same as 1 all over 10 to the power of a positive 1. That's 1/10. Whereas 10 to the power of minus 4, if you want to take it out of negative powers using rules of indices, that would be 1 all over 10 to the power of a positive 4. 1 over 10 to the power of 4 is the same as 1 all over 10,000. 1 over 10,000 is a tiny fraction in comparison to 1/10. That is a smaller number. So therefore, 10 to the minus 1 is a larger number than 10 to the minus 4. Okay? So I'm putting the larger number over the smaller number, and then you're going to subtract the power. So it's going to be 10 to the power of minus 1 minus a bracket minus 4. A minus by a minus becomes a plus. So it's 10 to the power of minus 1 plus 4, which is 10 to the power of 3. So therefore, your answer is the two numbers differ by 3 orders of magnitude. Okay, we are now done with orders of magnitude.